Okay, we will begin shortly. Before we start, I just like to confirm that you guys can see me and hear me as well, and then as well as see my screen. Just hear me clearly and you're able to see my screen. Please let me know in chat. Let me just enable chat so that you guys can type. Okay, now you can type. So just let me know in Zoom and as well as YouTube if you guys can hear me. Okay, perfect. Okay, cool. Sorry for being late. We just ended the previous class slightly late. Okay, assalamu alaikum and hello, good morning. Welcome, guys. Welcome back to grade, I believe this is grade 10 mathematics by Inspired Teens. Perfect, cool. Okay, so today we'll be continuing off where we left off from last week, which is algebraic expressions, and we're going to try and get through as much as possible. I think you guys probably in school right now have started exponents, equations and inequalities, and we'll get there eventually, right? Please do remember, if you guys have any questions, please feel free to let me know via the chat, Q&A, or alternatively the YouTube chat if that's where you are watching this from. Okay, so last week we ended on difference of two squares. Okay, today we're going to start off by doing a binomial by trinomial multiplication. Okay, so again, this is still part of simplification. Okay, all of these are simplifying algebraic expressions. And then eventually we are going to get to factorization. So binomial by trinomial is simple. Okay, so let's get rid of this. Okay, so right here, all we need to do is, I'm actually just going to rewrite it here. A minus 2, a squared minus a plus 1. Okay, so we need to multiply these two factors by each other. Binomial, remember binomial is 2 terms, trinomial is 3 terms. So all we need to do is we need to take the first term in the binomial and multiply it by each term in the other bracket. Okay, we take it step by step. Thereafter, we need to do the same thing for the second term. So the second term in the binomial and multiply it by each term in the trinomial. That's basically what we're doing. We're multiplying it out. We're actually distributing, but with 2 terms. Okay, so that's exactly what I'm going to do. A times a squared, that's going to give me a cubed. A times negative a, that's negative a squared. A times 1, that's plus a. Let's do it with 2. Negative 2 times a squared is negative 2a squared. Negative 2 times negative a is positive 2a. And negative 2 times positive 1 is negative 2. Please, if there are any calculation errors, let me know. A to the 3. Okay, now we just simplify, identify our like terms. So this guy and that guy are like. This guy and that guy are like. Okay, so those are the only ones we simplify. Write it in descending power. So the highest power we write first. So a cubed minus 1a squared minus 2a squared is minus 3a squared. Plus a plus 2a is plus 3a. And we have our constant term, which is negative 2. Okay, let's do one more example. So again, we're multiplying it out, right? Each term by each term. So I'm going to say, start off by saying p times p squared, which is p cubed. Then p times negative pq, which is negative p squared q. Because now I have 1p, another p, that makes p squared, and then 1q, right? And now p times q squared, which is plus p q squared. Okay, then what I want to do is I want to use q. So q times p squared. Let's do it. So that's going to give me plus p squared q. Okay, I think I'm writing in alphabetical order. A, B, C, D, F, G, H, I, J, K, L, M, N, O, P, Q. I am writing it in alphabetical order. So that's what you want to try and do. You don't want to have them mixed up, right? It's just easier for you to work with. Q times negative PQ. So that's negative P and Q squared. Then finally, Q times Q squared, which is positive Q cubed, Q cubed. Now I simplify, identify my like terms. P squared Q, P squared Q, PQ squared, PQ squared, and I simplify. So P cubed minus pq squared and plus minus p squared q plus p squared q cancel each other out. And as well as pq squared minus pq squared cancel out. It's like 1 minus 1 for both of them. Plus q cubed. Okay, cool. In the last example, you guys can practice on your own. Okay, so that's binomial by trinomial. Let's look at some mixed questions. Follow BODMAS, simplify in brackets if possible, square binomial, FOIL or binomial by trinomial, distribution, add or subtract items. Okay, so this is a combination of everything. I'm going to do the first example and you guys can do the second example. So this is just all of it combined, just a bunch of simplification. So here, for example, I have a monomial times a trinomial. So that's basically just distribution, right? Here I have a binomial by a binomial. Okay, so I'm going to do those. So I'm going to multiply 4x and 4xy. That's going to give me 16x squared y. Okay, you multiply the coefficient by the coefficient and like variables by like variables. 4x times negative 16y. That's going to give me negative 64xy. 4x times 12. That's going to give me 48x. Now, remember, this negative is extremely important in the next part of the question. So I'm going to leave it out for now, and then I'm going to multiply these guys first. Okay, I'm going to leave my negative there, and I'm going to keep the bracket because this negative is for all of these terms. Okay, it's going to change all of them. Now I'm going to do this binomial by binomial or FOIL, first, outer, inner, last. Okay, first is going to give me 2x squared. Outer is going to give me negative 2xy. Inner is going to give me plus xy. Last is going to give me plus minus y squared. Okay, again, if there's any calculation errors, please let me know. So 16x squared y minus 64xy. Damn, the lights are not back yet. Okay, let's hope my laptop doesn't die. Minus 64xy plus 48x. Now, this minus is like a negative 1. So it distributes into the bracket. Okay, so it's negative 2x squared plus 2xy minus, they all change, xy plus y squared. Now, like terms, if you use a highlighter, it makes it easy. Do we have x? So I have x squared y. Do I have another x squared y? I don't. xy, I definitely have another xy. And that guy. X, do I have another x? No, I don't. X squared, do I have another x squared? No, I don't. So now I've identified my like terms. 16xy squared minus 64. Basically, because they like, you can just work with the coefficients. Minus 64 plus 2 minus 1. Minus 64 plus 2, that's minus 62. I think it's minus 63. Okay, minus 63xy plus 48x. Okay, plus y squared. Okay, I think that's it. If you want to arrange it in order of powers, you'd say 16x squared y plus y squared minus 63xy plus 4x. Okay, and this last example, you guys can practice, but that's basically a mixed example. The 2 times 2. Where 2 times 2? Okay, I'm not sure what you're talking about 2 times 2. Just let me know, please. Okay, then this last example, you guys can do that on your own. Let's move on to factorization. There's a missing term, 2 times squared. I see what you guys are talking about. Okay, so then what we do is we move this. Okay, let's not do that. Please don't crash on me. Okay. Okay, let's not do that. Just erase it. Okay, so minus 2x squared. Minus 63xy plus 4x. I think that's right now. Please do the last example. Okay, because you said please. Why can't I see the video? Try refreshing your app or close it. Okay, I'm going to do it quickly though, okay, because for the sake of time, we need to finish a lot, okay? Okay, so let's look at this. The first example, this is distribution, okay, brackets. Second example, distribution. Third example, distribution. Okay, I'm not going to simplify it. I'm just going to do the distribution, okay? 3a squared plus 9a, right? I'm multiplying 3 by each term. 3 times negative 10, negative 30. Now, look at this minus. It's actually the coefficient of this bracket is minus 2. So it's like minus 2 times a squared, which is minus 2a squared. Minus 2 times minus 6a is plus 12a. Again, you multiply coefficient by coefficient and then multiply like variables. How did we get 4x? A good question. How did we get 4x? 48x, sorry. Just took it down wrong. Okay, sorry. Yeah, again, just sorry. The errors. Okay, so yes, plus 12a, and then 2 times 9, negative 2 times 9, which is negative 18. Then plus 2, so plus 2a squared. 2 times minus 4, minus 8. Okay, like terms, I'm not going to simplify, but we can identify like terms. A squared, a squared. Sorry, just give me one second. Let me mute while we speak up the alarm. Right, come back. Okay, so if I identify the like terms, you simplify from there. Okay, sorry about that. Can you guys hear me and see me? Okay, perfect. Sorry, just give me a second to get my bearings. No chilling. It's really fun. Okay, cool. I think we're back everywhere. I think YouTube, everyone can hear me. One more second. Join the audio. I just want to double check one more time. You guys can hear me, see me, and see my screen, right? Perfect, 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 perfect. Okay, let's continue. So factorization is the inverse operation to product. That is when we want to put the brackets back into the sum. Okay, so basically, yes, factorization is when you want to go back to factors. Okay, in this case, with simplification, we always just multiplying everything out. Okay, that's not the case in factorization. So let's look at the steps. They say first look for a common factor. That's important. If a binomial, look for difference of two squares or difference of two cubes, which we're going to learn now. So common factor, dots, or sum/difference of two cubes. Okay, if it's a trinomial, then factorize. If it's in trinomial, check if it's in that form and factorize, right? Trinomial factorization. If four or more terms, group, so we can learn grouping by looking for patterns first, examples, difference of squares and perfect square trinomials. Don't forget to factorize as far as possible. Remember, terms in brackets can be considered as a variable. Okay, that doesn't really matter. Okay, so it's just a guideline as to when you need to factorize, how can you approach it in order to factorize? What are the different methods that you can use to factorize? So the first of which we are going to go through is highest common factor. So this is the most basic example, right? So it's the inverse of distribution. So we're going backwards from distribution. If we have to look at this example, 6y squared plus 12y, it keeps getting stuck. I'm not sure. Is that for everyone? Is that for everyone or is that just for that specific person? No, meaning it's not for everyone. Okay, so if it's for someone, then yeah, just refresh and join back. Okay, cool. So in order to factorize, right, we need to identify the highest common factor. So basically a number or an and or slash and, a variable that can go into both of these numbers. Okay, so in this case, right, so we work with the number, which is the coefficient, separately, and we also work with our variables separately. Okay, so we work with the coefficient and each different variable we work with separately. So in this case, let's work with the coefficient. The highest common factor between 6 and 12 is 6. Okay, because 6 can go into both numbers. When we look at the variables, what is the highest common factor between y squared and y? Okay, the highest common factor between y squared and y is always, whenever we're talking about variables, the highest common factor of variables sorry for the noise that my computer is making. I hope that it's not too bad. The highest common factor of variables is always the lowest power. Okay, always the lowest power, which in this case, between y squared and y, the lowest power is 1, which is y. So therefore, 6y becomes the highest common factor. And then we basically write what is left, if you want to call it what is left. How you get that is you would take each term and divide it by the common factor. So 6y squared divided by 6y plus 12y divided by 6y. Y and one of those y's cancels, 6 and 6 cancels, you're left with y plus 12 and 6 make 2, but y and y cancel, so you're just left with 2. Okay, so when they say it's the inverse of distribution, if you have to distribute this out, you would get back that answer again. So 6y times y is actually 6y squared. 6y times 2 is actually 12y. So there we go, the inverse of distribution. Cannot hear the voice. I think refresh as well. Okay, let's look at the second example, right? We're busy with common factor. We have 3a open brackets 2a minus b minus a squared open brackets 2a minus b. So in this case, okay, it says join the voice. Yeah, join the voice. You need to join the audio. Okay, so in this case, right, we don't have two terms, wherein we have a a common factor in each term. Okay, here our common factor is actually an entire bracket. Okay, so just for the sake of this question, we refer to this as our first term and our second term. Within our first term and our second term, we have something that is common. It's an entire bracket that is common. In the first bracket, we have 2a minus b. In the second bracket, we have 2a minus b. Okay, in that specific case, we take that entire bracket out as a common. It's like a lawnmower. Cannot hear the voice? Join the audio. Okay, type in chat. Somebody please join the audio. Okay, so we take this out as a common factor because now it's common in both terms. Okay, and then we basically, in this case, we would write what is left over in each term. Alternatively, okay, alternatively, can I pin a comment? No, I can't. Okay, alternatively, you could divide each term by a common factor. So if I had to take 3a and 2a minus b, obviously you don't want to be doing this each time. This is just to explain how it works. That would cancel. I'm left with 3a. A squared, 2a minus b. I divide by my common factor, which is 2a minus b. That and that cancels because they're the same, and I'm left with a squared. Okay, so in this case, right, you're just left with whatever's left over besides the bracket. In this case, it's 3a and minus a squared. So you would have your common factor, okay, 2a minus b, and then whatever's left, 3a minus a squared. Okay, yeah. If there's an issue, if you've connected to audio or whatever, yeah, try resetting. It might be your network. Okay, so that's what we're left with. Right, let's move on to the next one. Now we have x, open brackets, x minus y minus 4 into x minus y squared. Okay, so this is basically like having x minus y times x minus y. At the end of the day, we have these common brackets. It's an entire bracket that's common. However, in this one, we have 1 of x minus y. In this one, we have 2x minus y's. It doesn't matter because in both, at least 1 x minus y is common. Okay, at least 1 x minus y is common. Let me just double check that. Okay, so in that specific case, I take my common factor of x minus y. Within the first term, I'm left with x. And in the second term, minus 4. And I have the second x minus y that I'm left with. So basically, I'll be left with minus 4 x minus y. Because, remember, it is x minus y squared. X minus y squared. Okay, so since it's x minus y squared, we actually have 2x minus y's. And in that case, we'd be left with x from the first term. After taking our common factor of x minus y, we left with x from the first term. And from the second term, negative 4, as well as 1 of the x minus y's. Okay, remember, it's technically still an exponent. And remember, we said what about highest common factor of variables? It's always the lowest power. And technically, here we have x minus 1 to the power of 1. X minus y to the power of 1 and x minus y to the power of 2. So the common factor there would be the lowest power, which is x minus y. X minus 4, it is fine. Now, can't leave a bracket inside of a bracket. Yes, you can leave a bracket inside of a bracket. That's fine. Okay, remember, we are not simplifying. We are factorizing. We factorize this more? I don't think so. If you'd like to leave it in a square bracket, x minus 4 into x. Okay. Okay, you most likely won't be dealing with examples like this, but this is just to understand the idea of a common factor. Okay, let's talk about sign change, which is important, right? Now, the change of sign in a bracket to make factors the same. No, blah, 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 blah. Okay, let's just learn it through the example, right? So now let's look at this example. We have 4a, a minus 2b in brackets, minus 6, 2b minus a. Now you'll notice like, okay, in this case, we're not going to take like the most basic. Yes, correct. Thank you. Right. So you're not going to take the most basic common factor. You're going to take the bracket common factor. Right. However, we have a minus 2b, but here we have 2b minus a. Now with addition, if I had to have a plus 2b and 2b plus a, these would be the exact same thing. Okay. These would be the exact same thing. I think it's called the commutative property of, no, it's not the commutative. It's the something property of addition, right? It's grade 8 work. Okay. So in this case, however, when we have a minus 2b and 2b minus a, those are not the same thing. So we cannot take this as a common factor. So we call this the sign change. We can actually change this sign. So we want this guy to be a minus 2b as well. We want him to be a minus 2b. Whenever we change the sign inside of the bracket, we also change the sign outside of the bracket. So instead of it being minus 6 into 2b minus a, we've changed it to plus 6 and then swap this around to what we want, which is a minus 2b. And then, of course, this remains the same. And now we can see that our common factor is actually a common factor now. So this becomes our common factor, okay? A minus 2b. And what are we left with? We are left with, correct, in chat, I see someone has 4a plus 6. What we are left with, this and that. You make the negative 6 a positive, so you can change minus at the back. Correct. Okay, and this does not change the value of it at all. It's the same thing. Okay, so keep that in mind. Okay, let's look at the next type of factorization, and that is, and you use, yes, a minus 2b as a common factor. Yes, you may, and technically you should, okay? Okay, so remember, okay, so this person says, can you use 2 into a minus 2b as a common factor? Yes, you actually should. Not that you can, you actually should, because you want to factorize it as much as possible. Thank you for that, right? You want to factorize it as much as possible. So technically, we can take a common factor with the coefficients as well, the numbers, okay? Because there's a common factor between these numbers as well, and that is 2. Okay, so my common factor is actually 2, because I can take a common factor of 2 in each term, as well as a minus 2b. So this is my entire common factor. Okay, you can treat it as like one common factor, but you don't really have to, because you can just open up your brackets and see what you're left with. Now, remember, you're basically dividing each of these by 2 into a minus 2b. So when you divide 4a by 2, you're going to be left with 2a. And when you divide 6 by 2, you're going to be left with 3. Okay, thank you for that. But yes, technically, this is the final factorized form. Why? Because we can't factorize it further, and we've taken out all the highest common factors and sign change. Do you change only the second bracket? You just want to change one to the other. In this case, I chose to change the second one for it to be like this, like the first one. Because now if I change the second one and then change the first one, then I'm going to be left with 2 different things as well. Can we multiply the 4a from all the number? Can we multiply the 4a? No, we do not. We're not multiplying out here. That's simplification. We're not distributing. Okay, we are doing factorization, which is the inverse of simplification. Yes, we will do trinomial factorization. Okay, cool. Let's move on. Right. Let's talk about difference of 2 squares, which is dots. We went through it briefly in the previous lesson. Okay, I'm not going to go through that, but it's basically exactly what it states. It's the difference, which is a negative, of two different squares, perfect squares. Okay, so let's look at the first one where they say factorize fully. Okay, so you need to be able to identify if something is a perfect square. Okay, so when it comes to the actual coefficient, the number, it needs to be a perfect square, right? So what are my perfect squares? 1, 4, 9, 16, 25, and so on, right? 36, 49, and so on. Okay, so it needs to be a perfect square, the actual number. However, when it comes to a variable, remember we said where is it? Any even exponent is a perfect square. So let's just say coefficient. And the variable exponent, any even exponent, is a perfect square. So in this case, we have a squared and b squared. Obviously, a squared and b squared, those are perfect squares because they're squared, but they're also an even exponent. So therefore, we definitely know that they're perfect squares. So when it comes to dots, okay, simply, if we have a squared minus b squared, we're going to square root each term and create two factors. We're going to have a minus b and another bracket that has a plus b 100% of the time. If it's dots, aka difference of two squares, this is the method that we follow. Okay. So now in this case, remember this part, this is like our a squared. So I need to square root 4a squared. The square root of 4 is 2. The square root of a squared is actually a. Okay. Minus square root of 64 is what's the square root of 64? 8, I think. And the square root of b squared is b. And then we're going to have the exact same thing, 2a plus 8b. No variables aren't the same. No variables aren't the same. Could you please rephrase? I'm not sure exactly what you mean. Like, do you mean about a squared and b squared? They don't have to be the same as long as each individual term is a perfect square. Then you are doing the difference of two squares. Okay, I got you. Okay. Okay, let's look at the second example quickly. Okay, so there's no dots here initially. Right? There are two terms, but not perfect squares. All right. So we're going to try and do some other type of factorization. We will notice that we have common brackets. However, no, you can't take out 4 as a common factor because 6 is not divisible by 4. 6 is not divisible by 4. It has to be a factor. HCF, highest common factor. It has to be a factor of 6. We are not doing like, we are not taking out 4 and subtracting it. We are not saying this 4 minus 4 and 6 minus 4. We are considering factors of 4, which is 2. Factors of 6, which is 2. Okay, we are doing highest common factor. I hope you understand that. Must always be 2 brackets in dots. Yes. No 4 can go into 64. I'm confused. I don't understand what you guys mean. If you're talking about the previous question, this question, just if somebody understands, just clarify. Okay. Yes, in this case, we have a common brackets. However, they're not perfectly common. Why? Because they're opposite signs, and with negative, that makes a difference. So this is an example of change, sign change. In this case, I'm going to have x squared. I'm going to change the second sign. X minus k minus y squared. Why did I change the sign? Because I know that I'm going to change this sign inside. Now, you might be thinking it's upside down, but all I did was negative k plus x. I just automatically reshuffled it, put the x front, just to make it exactly like that. Okay, that's the easiest way. Okay, they're talking about number 1. It's better to use 8. 4 is a common factor. No, there is 4. We're not doing common factor. If you'd like to take a common factor, you can take a common factor of 4. Okay, I think I finally get what you guys are saying. Okay, yes, you guys are correct. I'm confusing myself, or are you talking to someone? Okay, if you'd like to take, yes, technically you should be taking the factorize fully, so you take common factor, then that's okay. I get you. Sorry. Finally, I just didn't understand you initially. But yes, that is correct. Okay, so you're going to take your common factor out first and then do dots. No, it's okay. Okay, so you can take out your common factor first. That was my mistake. Yes, you have to take out your common factor. We are trying to factorize completely. Once you take out your common factor, then you can still do dots. Okay, so in this case, a squared minus 16b squared. So now you can do dots. So you square root a minus 4b, a plus 4b. Correct. Tell us what to focus on in the exams, maybe closer to exams. Yes, correct. Okay, let's move on. But yes, that is correct. Let's finish this example. So now, remember, we have, thank you for that, whichever student that was. So now we have common brackets, right? And they are both the same sign. So I'm going to take those common brackets as a common factor, and I'm left with x squared minus y squared. So I've taken the common factor. Now I notice that in one of my factors, right, I can do dots. This is dots because I have a square minus a square, perfect square minus a perfect square. So x minus y, x plus y. And then we're done. Okay, I'm going to get to your guys' questions in a bit. This example. Okay, you guys can do this example. Let us move on to grouping. It must be 68 because 4 times 16 is 64. Okay, I'm not sure I understand what that is. Okay, for what to focus on in the exams, that'll be closer to exams. Full method. Okay, we're going to go through that. What time will this lesson end? At around 55. Okay, with regards to the test, I can give you some questions and then you guys can go through those questions, right? Okay, let's talk about grouping. So used in 4 terms, used if there are 4 or more terms. First group, then do HCF. Groups can be due to HCF, difference of 2 squares, or perfect square trinomials. So when it comes to grouping, right, what we want to do is we want to group terms which we can take out the highest common factor of. Okay, so terms that have something in common. For example, if I look at the first 2 terms, 9d and bc, they have nothing in common, and I cannot take out a common factor between those 2 terms. If I have to look at the last 2 terms, bd and 9c, they have nothing in common, and I cannot take out a common factor for those 2 terms. Okay, so now in that case, what I want to do, okay, is I want to group terms according to, so that I can take a common factor. So we're going to try 9d and bd and see if we can go further. 9d minus bd plus bc minus 9c. Okay, so the reason I've grouped it, I've just rearranged it, is because I know that there's d common in the first 2, and in the last 2, there's c common. So now I can take a common factor, okay, with each binomial respectively. So in the first one, I'm going to take out the common factor of d, and I'm left with 9 minus b. In the second one, I'm going to take my common factor out of my common factor of c, and I'm left with b minus 9. So your signs are not going to change for rearranging because you're not taking it to the other side of the equation. This is an expression. I don't know if I discussed it with you, but remember the difference between an expression and an equation is an expression just has terms, okay, and an equation has terms with an equal to sign. That's for sign change. Yes, I think both are your favorite is sign change at this point. We've been through like 5, I think. Okay, but Yes, so now I have grouped my terms, okay, with anything that's common. If I have terms where they have something that's common, that's why I group them. And now, after I've taken the common factor with each one, and now I can actually factorize further. Yes, correct. Nothing changes if you're just grouping. Okay, so now it's sign change because I noticed that I have brackets that are common, but not really common because the signs are opposite. So then I know that I can change the signs. I change the middle sign and then swap this bracket. And now I have the common brackets. And now I can finally take that as a common factor. So 9 minus b is common, and I'm left with d minus c. If you were curious, if you had taken 9d and 9c as common and bc and bd as if you grouped it like that, it would still work. Won't all the numbers and alphabet go in one bracket separately? Okay, I'm not sure I understand your question. But if they're saying no, then I think the answer is no. If you can rephrase your question, then please rephrase your question. Okay, that's grouping. Like grouping is not that difficult. Okay, generally after grouping comes a factor with a bracket. Okay, confused about, are they talking about like terms? Okay, can you please explain to me what you guys are confused about, and then I can go through it. Then we're going to try, we have to get through at least trinomials and finish trinomials because we are going a bit slow at this point. Do I need to show the step in sign change? No, you can show it just like this. You don't have to. But ideally, yes, you do want to show the step. Okay, if you guys are confused for this grouping is anything to do with grouping, let me just do the second example. Okay, so we have 2a minus 3b plus 4a squared minus 9b. So I'm looking for highest common factors. Nine plus 5, a plus b. Okay, just listen to the second example and tell me if you're still confused because I still don't understand the question. Okay, so we have 2a minus 3b. Okay, so again, we have 4 more terms. So we're going to try to group in order to factorize. Please answer number 3. There isn't time. We should have time to at least go through factorization. We're going to end slightly late. Okay, 2a minus 3b. So again, there's nothing common between 2a and 3b. So I need to group it differently. If I group 2a and 4a squared, yes, I can get common factors there. And then I can group negative 3b and negative 9b squared, then I can get a common factor there. So let's do that. So I'm going to have 2a plus 4a squared minus 3b minus 9b squared. Okay, so now what is common in the two? So in the first one, I can take out the common factor of, firstly, we look at our coefficients. What's common between 2 and 4? What's a factor of both? Highest common factor of both? That would be 2. So my common factor for the coefficient there would be 2, as well as variables. Now remember, the highest common factor with variables is always the lowest exponent. So 2a, correct. And I'm left with, like I divide each term by the common factor. So remember, because this was 2a and my common factor is 2a, I'm not left with 0. It's like 2a divided by 2a, which is 1. So I'm left with 1. Okay. Plus, I divide this by 2a, I'm left with 2a. Minus, okay. So now I'm taking a common factor of negative in this case, right? So that is important, right? Let's see how it's important. Let's first identify what's actually common, or what's the highest common factor between the coefficients. It's going to be 3. And between the variables, it's just going to be b. Why? Because we want to take the lowest power. Okay. So in this case, I am taking a common factor of negative 3b. That is important, right? You could also technically take off positive, but we're just keeping that sign the same. But you need to remember you're taking a common factor of negative 3b. So it's like you are dividing each term by negative 3b. So actually for this one, I'm not left with negative 1, I'm left with positive 1, because remember when I multiply out my bracket distribution, I'm going to be left with negative 3b times 1 is negative 3b. So that's correct. It's like how it was before. But if I had to put negative 1 here, it would change to plus 3b, which is incorrect. So just keep that in mind. You're actually taking out a common factor of negative 3b. So this becomes 1. And this is also a common factor of negative 3b. So you're dividing 9b squared by negative 3b. It changes to 1 plus 3 goes into 9 3 times, and you're left with just b. Why is it 1 plus 2a in brackets? Okay, because you are dividing each term by the common factor. So you will write your common factor in front, then open up some brackets to see now what you have left. Okay, so what you have left is when you divide by that common factor. So when I divide that, I get 1. When I divide that, I get 2a. The brackets don't always have to be the same. Like in this case, if the brackets are not the same, then it's factorized completely. I'm just trying to think, is there any other way we can factorize this here? I don't think so. So this would be our final answer. So if they are the same, you factorize further. If they are not, yes, correct answer. If they are not, then that's your final answer. How long should we take to answer this question? Depending, yeah, like that person said, 1 to 2 minutes, 1 minute probably. If you're really struggling, 2 minutes. Let's talk about trinomials. Okay, just keep in mind. Have you guys learned something called the quadratic equation? I don't think you have. Okay, you guys have. Okay. It's not necessary for me to just assume such. Okay, so when it comes to trinomials, right? No, yes. Okay, some concerning no's, but either way, we're going to just at least start trinomials and carry on for 5 minutes. For those who need to leave, you may feel free to leave and then watch it later. If you understand, maths is fun sometimes. Yes, maths is fun sometimes when you understand the work. Okay, so trinomial steps. Okay, put in standard form, multiple. Okay, let's just do a practical example. So trinomial factorization is firstly when we have a trinomial, which means 3 terms. Okay, when we have 3 terms. Yes, just don't understand. Okay. Okay. When we have 3 terms, 3 unlike terms would create a trinomial, 3 different terms. As we can see, these are unlike because their variables are different, right? This has a squared variable, this has a squared x variable, this is just a single x variable, and this is a constant with no variable, right? So that creates a trinomial. So we have 3x squared plus 7x plus 2. So your first step is to open up your brackets. Okay. Now, once you have your brackets opened up, ladder method, okay, that's also a method. You are going to utilize the factors of the first term and the factors of the last term. We are going to utilize the factors of the first term and the factors of the third term. So the factors of your first term are going to give you your numbers in the first parts of each bracket, and your factors of your third term, okay, are going to give you the numbers in the last space. Can we do an easier one, perhaps? Okay, we're going to start off with a bit of an easier one. Okay, we're going to reach it in a bit. Okay, so let's factorize this. The first step is we can actually take out a common factor of 2. I'm left with minus 7x minus 30. Okay, we actually don't have to have the equation, so I can get rid of that. We're just factorizing it at this point. Okay, so remember I said that we are going to use, firstly, we open up our brackets. Okay, the factors of this first term is going to give us our numbers in the first sections of each bracket, and the factors of our last are going to give us the terms in the last portion of the bracket. Okay, so, right, the factors of x squared are simple. We only have one option for the factors, and the factors of x squared are x and x. Okay, so that's exactly what we're going to write. We're going to write the factors of x squared, one on each side. Okay, once we've done this, now we need to identify the factors of negative 30. Okay, so the factors of negative 30 are plenty. We have 1 and 30. Okay, we have 2 and 12. We have 3 and 8. No, 3 and no. Sorry, I was thinking 24. Okay, we have 1 and 30, of course. We have 2 and 15. We have 3 and 10. And what else do we have? 5 and 6. Okay, and that's all our factors of 30. Okay, so which ones do we choose? Okay, it's really important to decide. Okay, it's obviously really important, otherwise you're going to get the question wrong. But you have to choose the correct factors. Okay, so when we choose these factors, we actually choose them in pairs. So, for example, you can't choose 1 and 6. Why? Because those are not the factor pairs. You have to choose 1 and 30 if you are going to choose the factors of 30. If you're going to choose 2, you need to choose 2 and 15, 3 and 10, and 5 and 6. Okay, so keep this in mind. When you are choosing factor pairs, when you are choosing factors, you need to choose the factor pairs. Okay, so now which ones do we choose? Okay, so how do we tell which ones to choose? Is this middle number is key. Why is this middle number key? So there's many ways of telling it. Firstly, another method that we can use is outer inner. When we multiply the outer and the inner, we need to get the middle term. Okay, that's the first explanation. Right, I'll explain it to you simply in a second. When we multiply the outer and the inner, we need to get the middle term. The best way and the easiest way to tell which ones to choose, okay, in the factors of 30 is your factor pair, for example, 1 and 30, needs to, when you add it or when you subtract it, it needs to give you the middle term. When you add the factors or when you subtract them, it needs to give you the middle term. So for example, we can rule out 30 because when I add 1 and 30, I get 31. When I subtract 1 and 30, I get 29. Okay, so out. I need to get 7. I need to get 7. When I add 1 and 30, I get 31. When I subtract it, I get 29. Let's try 2 and 15. When I add 2 and 15, I get 17 when I add them, or when I subtract them, I get 13. It's not 7. Let's try 3 and 10. When I add 3 and 10, I get 13. Yes, you do need to get -7, but we'll talk about signs in a second. Okay. When I subtract 10 and 3, however, I get 7. So that's perfect because that is my middle term. Again, 5 and 6 doesn't work. You get 11 or 1. So the factor pairs that I'm going to choose are these lovely guys here, 10 and 3. We're going to end very shortly. Okay. 10 and 3. Okay. So now we also have something that helps us to determine the signs. Okay. The first one is outer inner. Another step is, I'm going to write them neatly next time. But the first step is you need to look, I'm just going to actually verbally do it now, and then we'll do it again next week written. You need to look at the second sign of the trinomial. If the second sign of the trinomial is a negative, one is going to be plus, one is going to be minus. If the second sign of a trinomial is positive, both signs inside the bracket take the first sign of trinomial. Okay. In this case, the second sign is negative. So one's going to be plus, one's going to be minus. Where you put it is important, like which bracket you put it in is important. However, in this case, my factors for x squared are x and x, so it doesn't matter. I can put it in either or, it would be the same thing. Now to decide where am I going to put the 10 and where I'm going to put the 3, because my factors are 10 and 3. That's also very important. It needs to go in specific places. How do I judge that? I do outer inner. So I'm going to multiply the inner terms and multiply the outer terms to get the middle term. Or in this case, alternatively, because one is plus, one is minus, you need to get -7 because that's the actual term. So you'd need to use -10 and +3 because -10 plus 3, as someone just said in the chat, is -7. We can change the sign to get -7 and so on. Okay, let's end it there because I'm going to be late for the next class. We will continue next week, okay, where we finished. All right. Yeah, we're going to finish up factorization, and our next topic is exponents, inequations, and inequalities. And then I think you guys move on to trigonometry. Okay. I mean, no problem. Thank you guys so much for joining. I will see you guys next week. Please, a reminder that the PDF will be sent to you guys. Okay, cool. Jazakallah khair. Assalamu alaikum. Thank you and goodbye. Actually, we have a few questions. So can I leave? Yes, you may. You can ask later. Can you first? Okay, I explained it. Okay, I'll try and give you guys questions. Okay, cool. Okay, thank you guys and goodbye.